Today we will be discussing the Hot Standby Routing Protocol, otherwise known as HSRP. Hot Standby Routing Protocol is a method to achieve near 100% network uptime, and this provides network redundancy for IP networks, ensuring user traffic seamlessly recovers from first hop failures in network edge devices or access circuits. In this topology, we are running two endpoint PCs that are emulated by Ubuntu Docker containers in GNS3. They are connected to their respective access switches, which are running Cisco IOSV Layer 2. The access switches are connected to distribution switches, which are also running IOSV Layer 2. However, we have configured these devices as Layer 3 switches in addition to its Layer 2 capability. We will be configuring virtual IP interfaces on these distribution switches, which are also running the EIGRP routing protocol and connected to our edge routers, which are running Cisco IOSV. So EIGRP protocol is running between distribution switches 1 and 2 and routers 1 and 2. That enables us for interconnection on our local area network. When two or more routers share an IP address and a MAC Layer 2 address, they can act as a single virtual router. The members of the virtual router group continuously exchange status messages. This way, one router can assume the routing responsibility of another if one is out of commission for either planned or unplanned reasons. Hosts continue to forward IP packets to a consistent IP and MAC address, and the changeover of devices that do the routing is transparent. When you use HSRP, a set of routers, or in our case, our set of distribution switches, works in concert to present the illusion of a single virtual router to the host on the local area network. This set is known as an HSRP group or a standby group. A single router elected from the group is responsible for distribution of the packets that hosts send to the virtual router. This router is known as the active router. The other router is elected, and that is known as a standby router. In the event that the active router fails, the standby assumes the packet forwarding duties of the active router. Although an arbitrary number of routers can run HSRP, only the active router forwards the packets sent to the virtual router. To minimize network traffic, only the active and standby routers send periodic HSRP messages once the protocol has completed the election process, which we will see here in a few. If the active router fails, the standby router takes over as the active router. If the standby router fails or becomes the active router, then another router is elected as the standby router. But in our case, we're only running two devices here, so there will only be one active router and one standby router. On a particular local area network, multiple hot standby groups can coexist and overlap. Each standby group emulates a single virtual router. The individual routers can participate in multiple groups, but again, for the purposes of this lab, we will be configuring a single group denoted here by HSRP Group 3. In this case, the router maintains separate state and timers for each group. Each standby group has a single well-known MAC address as well as an IP address. In most cases, when you configure routers to be a part of an HSRP group, they listen for the HSRP MAC address for that group, as well as their own burned-in MAC addresses. If you reference the quick notes, HSRP uses the MAC address of 0000 0 Charlie 07 Alpha Charlie, with the last two alphanumeric characters being the group number. So in our case, it's group 3, so it will be denoted as 03. That MAC address is important for a few reasons. One, when troubleshooting, you can view that MAC address and know that HSRP is in fact running. The second being that this is a definite well-known question on most Cisco exams, so you'll want to remember that MAC address as being tied to HSRP. All right. So first things first, let's pull up our distribution switches because these are going to be our heavy hitters for the day. All right, and if we run a show IP interface brief, we can see that these interfaces here have been configured to serve as our ERGRP members. However, our interface VLAN 1 is configured as our local area network gateways. And the same thing is true on distribution switch 2. Okay, so in essence, PC1's gateway is going to be .3 here, and PC2 will be .2. All right, and just so we're all tracking here, we should be able to pull up our PC1 and our PC2, which have been configured as host members. So running a ifconfig, we can see that PC2 is .40 on that subnet, and PC1 is .30. Okay, so PC1 should be able to ping its gateway, and as we can see here, it can. The same thing with PC2, should be able to ping its gateway, and it can. Now, in addition to that, we want to be able to target our edge routers. Our edge router here, so we'll take router 1 for instance, we can see that its IP address that is targeting the distribution switches to give it their routes is going to be 172.16.253.2. All right, and that's just gigabit 1 facing, so serving as its next hop. So in essence, since we are running EIGRP for that network, or for those networks, PC1 and 2 should both be able to target router 1. All right, and we can see that in our case here, they in fact can both target router 1. Okay, and that is simply based on our interconnection architecture. All right, so as we can see here, we've configured these switches to be redundant paths to both edge routers. However, if we were to take away, let's just say we suspend this link to our distribution 2, router 1 would hopefully pick up that path. Okay, so if we come back to our PC2, we should still be able to hit router 1. And the fact is, no, we cannot. All right, because we are not forwarding in accordance with that. Okay, so this is one reason why we definitely want to configure HSRP. All right, we do want a single virtual address, so if one of these routers or layer 3 switches do go down, the local area network hosts will have a single default gateway, and they will be able to have their IP traffic forwarded by that router that takes over as the active router, and providing that redundancy and survivability. Okay, so we'll resume this link for now. All right, so for now we know that PC2 and PC1 are both able to target and hit their gateways as well as both of their edge routers to access what's beyond. All right, so we are good to go there. But what we want to do is we want to bind these two layer 3 switches together to serve as that single gateway for all of our PCs here. Okay, and the way we do that is pretty simple. So what we'll do now, and if you notice, ERGRP messages, exchange messages are being displayed because we took that link down and brought it back up. Okay, but the command to display HSRP information is pretty simple. It's show standby. All right, and in this instance, on both of these switches, we can see that HSRP is in fact not running. Okay, so what we're going to do is we're now going to make these two devices members of the HSRP3 group. Okay, and the way that we do that is simple. So we're going to enter our VLAN interface. Okay, and you'll notice here we're using VLAN 1. That's not recommended for real-world purposes because it presents somewhat of a security vulnerability as it's a well-known VLAN, and it is assigned by default by Cisco out of the box. So what we're going to do, just for purposes of the lab, we're going to stick to VLAN 1 for simplicity. So what we will do now is on distribution 1, we'll go ahead and we will enter the command standby 3 to assign it that group number. And then we're going to assign the IP address that we want our local area network endpoints to target as their gateway. So 172.16.3.1. Okay, so we'll assign that, and then we will do the same thing on distribution switch 2. IP 172.16.3.1. Okay. So it takes a minute for our election to occur. All right, because right now HSRP has been configured on both devices. Okay, but the election does take a minute or two. So we can see that right now distribution switch 1 has targeted group 3 and has assigned that router as the active router. Okay, and on group distribution 2 for group 3, we have now been elected as the standby router. Okay, so what we'll do is I will do a do show standby, and we will be able to see more information about our HSRP configuration. Okay, so let's look through this. All right, so we have our VLAN, we have our group number, which is group 3. This router, in its case, is set to active. Okay, we see our state changes. Our virtual IP address is the IP address that we configured, so that looks good. And we can see our MAC address, and this is important, is set to that HSRP MAC address, with the exception of 03 being its unique identifier because we have assigned group 3. Okay, one thing to note is our preemption is in fact disabled. That is default. That's assigned by HSRP. We see our active router is local, which is stated in active. And then we have, we can see our standby router is 172.16.3.2, which is in fact distribution switch 2. And our priority number is assigned by default to 100. Okay? And we'll talk about that in later in this video. That's important. The two things I want to very much harp on here is what is the state? Ensure the MAC address is reflecting an HSRP MAC address. What is the state of our preemption? Is it disabled or is it enabled? And what is the priority number? In this case, it's 100 because that is the default. Okay. So what we need to do now is on our access switches, we need to configure an IP default gateway. Because right now, on our access switches, we do not have any default gateway. Okay, and since we are forwarding to that single virtual address, we want our access switches to be aware of what that gateway is in fact going to be. So to do that, very simple on a Cisco switch, we will simply configure IP default gateway, and then we're going to set that gateway to our HSRP virtual address, so 3.1. Okay, and we will do the exact same thing on access switch 2. And we will save our configurations. That's one thing we want to make sure we're doing along the way, is copying our startup or running config into our startup. Okay, so now our access switches are well aware that our default gateway is 3.1. Okay, however, our endpoint PCs still have their default gateways set to the distribution switch 1, which is 3.3, and distribution switch 2 for PC2, which is 3.2. We want to change that. We want all of our endpoints to be targeting that single virtual HSRP address. So what I'm going to do is I'm going to stop these containers, and this will vary by endpoint, but whatever your endpoint may be, what you're going to want to do is change your default gateway to the HSRP gateway. Okay, so I'm changing to 3.1. I'll save that. And then I'll go ahead and edit this configuration, and we'll change this as well to 3.1. We'll save our configs, and then we will start our devices. And as we do this, we want to ensure that we can, in fact, target our virtual HSRP address. Okay, so let's pull up our PC endpoints here. And let's go ahead and ping our HSRP address, and that looks good. All right, right now, both of our hosts are able to ping our HSRP IP address. Okay, looking good so far. All right, so as we just saw, HSRP automatically identified or elected our routers, or in our case layer 3 switches, as active and as standby. All right, we want to have control over that, okay, because we may be implementing HSRP because we have a router that we know is going down, but our uptime requirements are, very stringent. We need to have good uptimes, so we configure HSRP so we have a failover route for survivability in the event that that router in question does go down. We have an alternate path out to where we need to go. So what we want to do is we want to be able to elect this on our own. Okay? So the way that this is done, by default, HSRP assigns that priority of 100, all right, which is depicted here. But HSRP prefers a higher priority device as the active path, which you can manually set if desired. Only one active router can be used at a time. In this case, so if no priority is set, HSRP makes that election for you. Again, we are presenting the illusion for PCs to think that there is a single default gateway, which is accomplished by these routers working together as one. So let's ensure that the router we want becomes the active router for the HSRP group, and we'll assign a higher priority value. Okay, so in our case, right now we see distribution 1 is our active router. Okay, but what we want is we want distribution switch 2 to be our active router, because that distribution 1 may be on its way out. We have another one on back order. We're lead times are just, we're waiting on that router, whatever the case may be. So what we're going to do, again, we're still in our interface VLAN 1 here, and let me open this up. So what we're going to do is we're going to lower the priority on router or distribution switch 1. Okay, so the way we do that is we issue the command standby, and then make sure to assign your group standby 3, and then what we'll see is we'll do a priority and we'll set it to 90. All right, we'll open this up a little bit. Okay, and then from here we will come down to distribution 2, and we will do a standby 3 priority, and we'll do 120. Okay, so right now we have said, hey, the higher priority is going to be distribution switch 2. All right, and we want our standby router to be distribution switch 1. Okay, so we've assigned a lower priority on switch 1 and a higher on switch 2. So what do we see? So right now, in theory, distribution switch 1 should be the standby router. That's strange. It's still set to active. What about switch 2? Let's fix our commands here. We're still standby. Why is that? That doesn't make any sense. So we must enable preemption, as we talked about before, on both of our devices for this to take effect. Okay? If you notice, preemption is disabled. Okay? And that's on both devices. That's because by default, HSRP will, when configured, disables preemption by default. All right, so the way that we fix that is we, again, type standby in our interface VLAN, standby 3 or HSRP group 3, and then we will type preempt, okay? Go ahead and hit enter. Standby 3 preempt. So now, once we configure this on both devices, we should see a change. And we'll give it a second here. And as you can see, already, distribution switch 1 has changed from active to speak, and now from speak to standby. Take note of this terminology as well, because you will see that on some Cisco exams. Okay, and as we can see here, the distribution switch 2 has changed from standby to active. Okay, so if we do a do show standby, now we can see the distribution switch 2 is in fact our active router. Okay, everything else remains the same, our IP, our MAC. However, preemption is now enabled. Okay, and our priority is reflected in what we previously configured in order to make sure that we set our active and standby devices manually. Okay, and the same thing here, preemption enabled, and then the priority of 90. Okay, so everything looks good. All right, we'll go ahead, before we do anything, we'll make sure that we save our configurations. And once again, we'll come back to our PCs, and we'll just do a real quick check. Can we still hit our gateways, HSRP gateways? The answer is yes. What about, can we hit our router? PC2 can, and PC1 can. All right. Now, before, if you remember, what we did was we took down this link to distribution switch 2. Okay, and keep in mind, distribution switch 2 is our active router right now. So I'm going to go ahead and I'm going to suspend this link. So now distribution switch 2 is down. Okay, so I'm going to pull back up our PCs and let's see if we're still able to hit our edge router. All right, we are not able to hit that. So let's go back to our distribution switches and let's see what's going on. Okay. EIGRP has gone down. Which interface did I take down here? No, I took down the right interface. Huh. Let's look at a do show standby. Okay, so we're in speak. Distribution 2. Do show standby. Okay, so this is still active. And our distribution 1 is still standby. Are we able to ping? Yes, we can. Okay. So what happened there was it was taking a minute to elect its router. Okay, so essentially distribution switch 2 is still our active router. All right, and we'll just go ahead and confirm that. However, our standby has picked up the route, okay, because we have killed this link right here between all of it. So the standby router has picked up its path, and that's exactly what we wanted, okay? Because in essence, that virtual IP address is what we were able to target, and HSRP is in fact picking up that device, okay? So even though distribution switch 2 is still our active router, our standby has picked up that path. Now, if we were to shut distribution switch 3 down, then our active router would become our distribution 1. Okay, so in essence, that's HSRP. I hope this clarified some things about this protocol, and I hope you learned something today, and thank you for your time.